All right, number 13, a random sample of 1,006 adults in a certain large country was asked, do you pretty much think televisions are a luxury or a necessity that you could do without? Of the 1,006 surveyed, 538 indicated that televisions are a luxury they could do without. Complete parts A through E. So part A wants you to find the p hat, sample proportion, and so make sure I'm not writing off the screen. There we go. Number 13, the p hat is equal to x divided by n, and in this case the x that fit the description, 538 over the 1,006. 38. And we're going to round to 3 decimal places, so 0.535. When you round up, 535. So we want to verify the requirement. So remember, N P 1 minus P, sample proportion P hat, has to be greater than or equal to 10, and N has to be less than 5% of the population size. So one verifies that it's random sample, other verifies that it's independent because we didn't do too many people. The sample, blank, a simple random sample. So up here it says a random sample, so it tells us that for sure. It says a large country. We don't know the population size, but a large country, we're going to assume that that's going to be pretty big and that this is going to be smaller than. So verify that these requirements are satisfied. It's stated that it's a simple random sample. The value of NP1 minus P, so let's find out what that is. So if I do 1 minus P, that should give us 0.465, okay? So we're going to do N 1,006 times 0.535, 0.465, 250 point, 3 decimal places, 250.268, 250.268. Which is greater than or equal to 10, and the sample size can be assumed to be less or equal to 5% of the population size. All right, we're going to construct and interpret a 95% confidence interval. So now that they give us a level of confidence, we will move over to StatCrunch and complete the rest. So we're looking for confidence interval, stat, proportion, 1 sample, summary. Number of successes was 538. Observations 1,006. We want 95%. It's already there. So 95% confidence. Lower limit 504.504, and then upper limit is going to be 0.566, 504.566. So we are 95% confident that the proportion of adults who believe televisions are a luxury or could do without is between 0.504 and 0.566. Is it possible that a supermajority of 60%, more than 60% of adults believe that the TV is a luxury they could do without? So we can do a hypothesis test now. Is it possible? So let's see the probability. One sample, summary. So again, 538. 1006. Hypothesis test for P is, we got 0.535, and we want to see, is it possible that more than 95% confidence? So p-value is 50%. C-stat is really small. P-value is much bigger than alpha, which is 5, so that means we would fail to reject. We would fail to reject the null, which means it is not likely. So I don't know if we want to say possible, but not likely. That a supermajority of adults believe could do without, because the 95% confidence interval does not contain 60. Yeah, our confidence interval did not contain 60. The 60%. So we definitely want to say everything is possible, but it's not likely. All right, use the results of part C. Construct a 95% confidence interval for the population proportion of adults who believe that televisions are a necessity. So we are looking for the percentage that believe TV is a necessity. So if 538 out of 106 believe that it's a luxury, then the remaining proportion, which would be 1006 take away 538. So this will give me 468, which should be the same thing as the 465. That's the 1 minus p. So we're just doing it with the 1 minus p. Okay. StatCrunch, proportion, 1 sample with summary, number of success, 468 this time, observations, 1006. We're going to do a confidence interval, 95%, and we would get 0.434 to 0.496, 434 to 496. Now do also note that thinking about this, once we got the first kind of confidence interval, we can just do 1 minus these two numbers and get that same value. So if I did 1 minus the upper, that would give me the lower bound, because that's the bigger number, 0.566. Gives me the 0.434, and if I did 1 minus 0.504, but you just got to know that relationship to think to do that. So you get those same two numbers, 434 and 496.